Greetings and hello, and thank you for looking at this little video clip here. I'd like to make a little set of proofs prove the four equations of kinematic equations of motion rather. And I have made a video similar to this one before, but I deleted it. It had the logo of a school I worked at previously, and I wanted to have the logo of the people who are funding this video, the Networks of Expertise, and I want to thank them for that, so I wanted to make this video with their logo on it. What I want to do today is look at the four formulae from NZQA, look at the two symbol systems that are used, and prove the four formulae in order with pause points so that if you wish to write it down, you can. And if you don't, you can roll past. So looking at a snip out of the 2023 NZQA booklet, the six equations are the definition of velocity, the definition of acceleration, and these four kinematic equations of motion, which I'll go through shortly. So we've got two symbol systems. We've got displacement. The rest of the world uses S. I personally prefer the rest of the world symbol, but I'm going to be using the New Zealand symbols. Initial velocity is V subscript I, and V subscript F is the final, U and V, and A and T are common to both symbol systems. If we look at a generic velocity time graph, where we have a final velocity which is different from the initial velocity, we have a certain amount of time. The slope is the acceleration, and the area under the graph is the displacement that has been produced. If we look at the four equations of motion, actually six of them, but the four equations of motion down the bottom right hand side here, we can look at this thing here as the slope of a velocity time graph is the acceleration. So therefore the acceleration is a rise divided by the run. And we have the difference in the velocities divided by the time covered. And if we swap sides and then multiply both sides by t, we have the difference in the velocities is the acceleration times the time, and I want to hold on to that. That is very, very important, that one there. So I'm going to come back to that, but I'm also going to develop it further. Both sides have, left-hand side has a minus I. I'm going to add VI back in. To maintain the integrity of the equal sign, I want to add a VI to the other side. So therefore we have the final velocity is the initial velocity plus A times T. In the old symbol system, the other symbol system which I like, V is equal to U plus AT. And that formula is written down here in the bottom right hand corner by my face. And I'm going to, this is a pause point, holding it for 3, 2, 1, moving along. The average velocity is the displacement divided by the time, and we can rearrange that to be the displacement is the average velocity times the time. If we look at the average velocity is initial plus the final, or final plus initial, divided by how many there are, that's 2. Then multiply that by the time, we get the displacement, and that's the formula that's given on the formula sheet. In fact, that's even a scan of it. And that's a very, very short proof. I'm going to leave that there for a very short amount of time. 3, 2, 1, that's your pause point, moving along. We can also look at that in terms of geometry. The average velocity is this value here, and multiply that by the time gives us the area of this rectangle underneath this dotted line. That's the same as the total area underneath this trapezoid because of the average, but it's also, we could look at it as though we put a hinge at this crossover point, picked up this triangle, rotated it, and dropped it into that little slot there. So the two areas are the same. It also shows that the displacement can be looked at in two different ways. We can look at the displacement another way. We can have the bottom rectangle, the area of that is equal to initial velocity times the time, and the top triangle, which is half times the base times the height, which is half times the time times the difference in the two velocities, Vf minus Vi. Oops, and then we can rearrange this here. So the total displacement is those two areas added together. At the bottom rectangle plus the top triangle, VIT, as before, half times base times the height, Vf minus Vi. However, earlier I said that Vf minus Vi, the difference in the velocities, is equal to the acceleration times the time. And we can then take, because it's equal, we can replace the bracket with the A times T. So D is equal to the VIT plus a half T times AT. Gather the like terms together, and we get VIT plus a half A times T, or displacement is equal to VIT plus a half AT squared. That's what we want. That's what was written in the formula sheet, and I haven't put the formula sheet back up, but that's what I wanted to prove. This is another pause point. Moving on in another 3, 2, 1, rolling along. We have one to go. We've got to prove this formula here. VF squared is VI squared plus 2AD, and the old formula, V squared is equal to U squared plus 2AS. We already have VF equals VI plus AT. If we square both sides completely, not just some of them, square both sides, the left-hand side looks promising. And then we expand it. And using the FOIL, F-O-I-L, first, outer, inner, last, we have VI squared plus, and then the outer, VI times AT, or AT times VI, inner, AT times VI, plus the two last ones multiplied together, A squared times T squared. We can then start gathering some terms, and we have 2 times A times VIT. Now I'm also going to add in here a little artifact here. If I multiply the last term by 2 and also by a half, I have no net effect, but it gives me a big plus. I can then pull out 2a as a common factor from the last 2 terms. I have VI squared, VF squared is VI squared, plus 2a as a common factor, times VIT plus a half AT squared. However, we've already figured out that VIT plus a half AT squared is equal to D, or in the old symbol system S. So we can have VF squared is VI squared plus 2AD, or V squared equals U squared plus 2AS. And that's another pause point. 3, 2, 1, moving along. And so here are the 4 formulae, plus the 2 definitions at the top, and these 4 formulae. And I'd like to thank the Networks of Expertise for helping put this together. Kia ora te whānau.